Hey everyone, welcome. Today, we're going to pull back the curtain on a piece of tech that is so deeply woven into our modern world, you're almost certainly using it right now, and you probably don't even realize it. We are talking about phased array antennas. All right, let's just jump right in. On the left, you've got the past, a huge, clunky, mechanically steered dish. And on the right, the present and the future, a sleek, flat, static panel. So what happened here? This is the story of a fundamental, absolute revolution in how we talk to the sky.
To really get why this change was so massive, we have to start with the old way of doing things. And let me tell you, it had some serious, major problems.
You know, the limitations of these old antennas were also physical. They literally had to move their entire bulky structure to point at something. That makes them slow, super heavy, and just full of moving parts, motors, gears that are just waiting to break down. And here's the real kicker. If that one motor failed, that's it. The whole system is down. A classic, catastrophic single point of failure.
So, faced with all these mechanical headaches, engineers came up with a solution that was just, well, it was truly brilliant. An idea that completely sidestepped the problem by getting rid of the moving parts entirely.
And this is it. This is the big idea. Instead of one giant moving part, what if you used a whole grid, an array, of tiny, simple, stationary antennas? And what if you could get them all to work together perfectly coordinated, so they act like one single massive, super powerful antenna that you could steer just with electronics?
Okay, but wait a second. How? How do you steer a beam of energy if nothing is physically moving? It kind of sounds like magic, right? Well, the answer is in this incredible bit of physics called beamforming. And this, right here, is the secret sauce. It's the absolute heart of this whole technology.
This quote really nails the core concept. It all comes down to wave interference. Just picture ripples in a pond. If you could create a bunch of little ripples with perfect timing, you could get them to all add up into one big wave in the exact direction you want, while they basically just cancel each other out everywhere else. That's precisely what's happening here, but with radio waves.
So that brings us right back to the million-dollar question. If all those little antennas are just sitting there, bolted in place, how do you actually aim that combined beam? It's this really ingenious four-step dance. First, you take your signal and you split it into a whole bunch of copies, one for each little antenna. Second, and this is the real magic trick, you apply a tiny, precisely calculated time delay to each of those copies. That's the phase shift. Third, each antenna radiates its own slightly delayed signal out into the world. And finally, boom, as all those little waves travel through the air, they interfere. They cancel out in almost every direction, except for that one sweet spot where they all line up perfectly and add together to form a single, powerful, focused beam.
And that right there, that is the whole ballgame. Because you're controlling those time delays with electronics, you can change them at pretty much the speed of light. You can whip that beam from one side of the sky to the other almost instantaneously, all with zero moving parts. It's incredible.
So once you have that kind of electronic control, it just unlocks this whole new level of performance. We're not just talking about fixing old problems anymore. We're talking about doing things that were completely impossible before.
The first thing you notice is just the raw, mind-bending speed. We're talking about the ability to scan the sky or switch between targets in microseconds. A mechanical dish couldn't even begin to dream of doing something like that.
And of course, no moving parts means they are just ridiculously reliable. There are no motors to burn out, no gears to wear down. This is a massive, massive advantage for any system that has to run 24/7 without fail.
And because they're essentially just these flat, solid-state panels, phased arrays are way more compact and a heck of a lot lighter than those old bulky dishes. This means you can integrate them seamlessly right onto the skin of a plane, the roof of a car, or the side of a building.
Now this is where things start to feel a little bit like science fiction. With the right digital processing, a single phased array panel can create and steer multiple, completely independent beams, all at the same time. It can track multiple targets at once or talk to dozens of different users simultaneously. It's a total game changer.
So let's just sum it up because it's a powerful list. They're fast, they're compact, and they're incredibly versatile. And I love this phrase, they degrade gracefully. What that means is, if one or two of the hundreds of tiny antenna elements fails, who cares? The system just keeps on chugging along, maybe with just a tiny dip in performance. It is the absolute opposite of that old single point of failure problem.
Okay, so we've geeked out on the what and the how. Now let's get to the really exciting part. Where is this technology actually showing up and changing our world?
right now. Well, the next time you see a 5G cell tower, just know that thing is absolutely packed with phased array antennas. It's the only way they can handle the massive amounts of data and connect thousands of users in a crowded city. They're literally steering individual beams of connectivity directly to your phone.
This tech is also the magic that makes modern satellite internet a reality. You've got these huge constellations of satellites just whipping across the sky at thousands of miles per hour. A user terminal on the ground has to track them perfectly and seamlessly. You can't do that with a motor. You need the insane agility of a phased array to keep that link locked on.
And the applications just keep going. Phased arrays are the all-seeing eyes for the most advanced military and aerospace radar systems. And more, they're becoming the key sensor that allows an autonomous vehicle to build a super detailed 360-degree digital map of everything around it, updating it thousands of times every single second.
So I'll just leave you with this final thought. This technology took us from these clunky, slow-moving machines to silent, solid-state panels that can steer thousands of invisible beams at nearly the speed of light. It's a quiet revolution that has already completely reshaped our world, and it really makes you wonder, what's next? If you can do all that, what can't we connect?